Writing equations of lines in slope-intercept form. So that slope-intercept form you're very familiar with is we want to make sure, there we go, we want to make sure that we become fluent, okay, in creating equations of linear functions, meaning we want it to be very automatic. We will concentrate on learning how to form equations in slope-intercept form. So that slope-intercept form is your famous y equals mx plus b. So using function notation, we can change that y to f of x equals mx plus b. And we're given two parameters, okay, where the two parameters are slope, which is your average rate of change, and your y-intercept. So your parameters are your slope and your y-intercept. So you guys are going to do question number 1 on your own. It pertains to the graph over here. So you're going to do A and B to come to class with. So let's take a look at what about if the y-intercept is not an integer, okay? So in the last one, it was an integer. So we can still find that y-intercept even if it's not exact, if it's not an exact integer. So it says find the equation of the linear function in slope-intercept form, and then we're going to test our equation for x equals -4. So in order to find the equation of this line, if I'm going to start and find the slope, so I can pick any 2 points on my graph that cross at a nice grid line. So I think that one looks good, and that one looks good. So if I work with those 2 points, so this point here is 2, 1, and this one is -1. Sorry about that. Whoops, don't know why it keeps moving. -1, 2. So I could use my slope formula, my change in y over my change in x, or because we're given a graph, we could just do good old-fashioned rise over run. So we know we are rising up 1 and going back 2. Know that -1 over +2 is the same thing. Okay, oops, I made a mistake. What was my mistake? You're probably saying, Mrs. Swinson, you need to count correctly, and we're going back 3 on that. Sorry about that. Okay, so we've got my slope, but as you look here, we can't find what the y-intercept is. Okay, it doesn't cross at a nice grid location. We know that it's right there, but we can't tell exactly what it is. So if we've got these 2 points, I can pick any point I want to work with. I'm going to pick that one just because. You could pick the other one, it doesn't matter. So thinking about my y equals mx plus b, I know that y is 2 from my point. I just found my slope to be -1/3, and my x is -1, which then allows me to find out what b is. What is the y-intercept here? So I end up with 2 equals +1/3 plus b, subtracting 1/3 from both sides, and I end up with b is 5/3. I'm going to pause for a second here. Okay, I'm back. So my b is 5/3, so I have the 2 parameters that I need to write this equation. So y is equal to -1/3 x plus 5/3. So they want us to test that equation when x is -4. So if I take and sub in that -4, I'd get y is equal to -1/3 x times -4 plus 5/3. So y is equal to, this is going to give me 4/3 plus 5/3, which, whoops, I was ahead in my brain there, which is 5/3. That's going to give me 9/3, which is 3. So how does that help me sort of test this? So does the point -4, which they gave us, comma 3 exist on this line? -4, 1, 2, 3, 4, +1, 2, 3. There it is. So there's a nice little check to see that that equation is correct. let's go ahead and flip the page. And you guys are going to do, I'm going to give you the answers for A and B if you want to practice with those, but you're not required to. But I will give you those answers, okay? There's never too much math that you can do. It's always good practice. So those are those two equations for A and B. I'm going to have you come to class with C done. D, we're going to do together. And what they're asking us to do is to write our equation in y equals mx plus b form. So if I've got my 2 points here and I don't have a graph, I've got to start with my change in my y over my change in my x. So 19 minus 4 over 12 minus 3. So that leaves me with 15 over 9. If I simplify that, I end up with 5/3 as my slope. So now I've got to find my y-intercept. I will always go and pick the first point that's listed. It doesn't matter which point you pick. So 4 equals my slope times my x plus my b. So doing a little math here, we end up with 5 plus b. Solving for y, I end up with b is -1. So I have my 2 parameters. I have my slope and I have my y-intercept. So my equation is y equals 5/3 x minus 1. Okay, and we're going to do question 4 together. We've got a little application here. It says a car is traveling along a straight road. After 1 hour, the car is 72 miles from Chicago. After 3 hours, the car is 188 miles from Chicago. Determine an equation for the distance d the car is from Chicago h hours if the relationship between d and h is linear. Okay, so we have to sit and think here. We've got 1 hour at 72 miles. So that could be considered my x and my y. And then after 3 hours, the car is 188 miles from Chicago. So that's my other x and my other y. In other words, I can name these x1, y1 as my first point and x2, y2 as my second point. So 172 and 3, 188. So I'm going to go through that same process. I've got to find my slope, okay, or my average rate of change over 3 minus 1. And then I end up with 116 divided by 2, which is 58. And that's a rate, so that's 58 miles per hour. Now I've got to find that y-intercept. So again, I will always pick the first point listed just for ease. Y equals mx plus b. So my y is 72. My slope that I just found is 58 times the 1 plus the b. B is equal to, solving for that, I end up with b is 14. So I found my 2 parameters. Now they want us to write it in terms of d and h. So distance equals 58h plus 14. Okay? All right, we'll see you in class.